speed measurement. So these are the contents, that is introduction, methods used for the speed measurement, and references. So here actual the rate of change of position of an object is in any direction is called as a speed. I have already specified when we people were bifurcating distance and displacement. So distance is nothing but it is speed upon time, and displacement is nothing but it is velocity upon time, and both the terminologies are measured in terms of your meters, that is distance and displacement. Here we people are defining a speed. So looking towards the definition, it has been specified as a d is equal to distance upon time, and to define a parameter or a unit for the speed measurement, d is measured in meters as we have previously discussed, and time is measured in seconds. So the unit for the speed can be considered as meter per second. So here I have already specified that S is the speed for the formula which has been given as meter per second. D is nothing but the distance traveled either by a vehicle or a human. It is in terms of meter, and time is nothing but time taken to cover that particular distance. So it is measured as a ratio of distance to the time in which the distance was covered or distance is covered. So speed is a scalar quantity as it has only direction and it is not having the magnitude. Commonly, we people are saying that it is when we people are traveling, it is not having the magnitude. However, it is having a particular direction. That's why it is a scalar quantity. Now, what are the devices that are used for the measurement of speed? Tachometer is the best example for the measurement of speed, and tachometer is used for the speed measure. It can be used to measure the speed of a rotating shaft. How it is used, that I will explain as we people will move ahead. So it can also be used to measure a flow of a liquid. Now, how the flow of a liquid is measured? Now, if suppose we have connected a wheel attached to a shaft, and this shaft is connected to the tachometer, variation in the flow will try to rotate the wheel or increase or decrease the speed of wheel. And as your shaft is connected to wheel and tachometer is attached to the wheel, automatically the tachometer will try to provide you the output. Different types of tachometer. Now tachometers are broadly classified as mechanical tachometer, electrical tachometer, contactless electrical tachometer. So it is briefly categorized into three parts, that is mechanical one, which is associated or subclassified into five categories, that is revolution counter, hand speed indicator, then tachoscope, centrifugal tachometer, and resonance, that is nothing but the vibrating reed tachometer. Then your electrical tachometers are further subclassified as eddy current or drag cup tachometer or tacho generator. These tacho generators are further classified as AC tacho generator and DC tacho generator. And finally, the contactless electrical tachometers are bifurcated into three categories, that is magnetic pickup tachometer, photoelectric tachometer, and stroboscope. So briefly, we people will go for one by one type of tachometers, which is a much more commonly used device for the speed measure. Now, tachometers can also be classified on the basis of data acquisition, contact or non-contact type, and can also be classified on the basis of measurement technique, that is time based or frequency based, or either it can also be classified as analog type or digital type of tachometers. So these are further classification of the tachometer. Either you can use contact type depending upon your application. You can use contact type, non-contact type, time based or frequency based, or analog or digital type of tachometer. The first part which we have considered is a mechanical tachometer. With a diagram, we people will see the mechanical type of tachometer. Okay, first one is your revolution counter tachometer. In this particular one, actually, as this revolution counter or that pointer is attached to the rotating shaft, it will try to provide you revolution, and this revolution will indicate the value how many revolution in a second or a minute it has covered, and based on that we people can determine the speed of rotating shaft. Generally, the revolution counter is used to measure an average of a rotational speed instead of instantaneous rotational speed. It consists of a worm and a gear that is usually attached to a spindle, and it has two dials. One is the inner one and another one is the outer one. Inner dial represents one revolution of the outer dial, and outer dial represents an revolution of a internal spindle. This tachometer has a stopwatch attached to the revolution counter and used to indicate the time. Now, here one important thing we have to consider, that how many revolution for that particular time after connecting this revolution counter is counted. And this stopwatch, when you people are interested to measure the speed, automatically what is going to happen, you are going to connect that particular device. When it will try to start rotating, your stopwatch will be on, and for 1 second, 2 seconds or a minute, you people will try to measure it, and number of revolution will be counted. So the speed limit is for in the range up to 2000 to 3000 rpm, means low speed engine. This particular device can be used for the low speed device. If you try to visualize this particular aspect, so this one is your inner dial, this particular part, and this one is your outer dial, and this is the spindle. Now if I try to connect a rotating shaft across this part, this is a rotating one, this shaft is rotating one, and this is the spindle actually. Now this spindle will try to rotate, and depending upon the rotation, your inner dial and outer dial will indicate up to what extent, and this is the actually means holding knob. So here, when this is connected to the spindle, when this is connected to the spindle, automatically what is going to happen, this spindle will try to rotate, and inside this one there are gears. So you can easily observe that these are the gears are provided. So when this will start rotating, this part will start rotating, as as this gears will also start rotating depending upon the speed, and here also there are gears. So what is going to happen? These gears will move, try to move in the forward direction, and it will take a rotation. So this dial will try to rotate, and you people are going to get the number of revolution. At allied side, how many revolution you have got for in a 1 second or in a 1 minute, that can be easily measured using this revolution type of counter along with a stop watch also. So this is the working principle of your revolution counter, and up to 2000 to 3000 rpm we people are measuring the speed, or a lower speed machine uh, that can be used for the measurement of the speed. Second one is hand speed indicator. Now this hand speed indicator has an integral stopwatch inside it and a counter with an automatic disconnect. This is somewhat moderate one, or this is somewhat upgraded compared to that of revolution counter. The spindle operates when brought in contact with a shaft. The pointer which I have shown in the similar manner, I will show that diagram also. When it is coming in contact with the shaft, automatically your spindle will start operating. Counter does not function until start and wind button. Means there is one button, as soon as though it is started to rotate, but the counter will not start till you press a push button which is present over it. So the instrument indicates the average speed overshoot interval in rpm, revolution per minute, and accuracy of this particular instrument is plus or minus 1% of the full scale. And the speed measurement of this hand speed indicator is having the larger range compared to that of the previous one. In previous indicator, actually, or counter, we people were able to measure 2000 to 3000 rpm, but same is not the case with hand speed indicator. You can even measure a speed up to 20 to 30,000 rpm using hand speed indicator. So these are the devices. If you try to observe, so this is nothing but this is your spindle, and this spindle is actually connected. Likewise, I will show that one. So here actually this is the shaft, this is the shaft, and this shaft is rotating. So when the spindle is connected, automatically the spindle will start rotating. And here is the button. So here your speedometer will try to rotate. This speedometer will try to rotate. But when your counter will start, the counter will start when you are going to press this particular button. Similarly, for this particular one, this is the spindle and this is the button. Using this button, you people can start the counter. Similar is over here. This is also. These are different types of hand indicators, or you people can use these different types of model depending upon the upgradation of that particular device. Okay, so another one is tachoscope. So if you try to observe a tachoscope, you people will understand the concept of the tachoscope. Here, tachoscope consists of revolution counter, and this revolution counter, if you see, there are two dial gauges. One is this one, another one is this one. One is this one and another one is this one. Here you people are having the two dial gauge, and here actually you people are trying to connect your this one. I will show that particular shaft. So here you people are connecting. So revolution as